They're infectious and pathogenic only to plants. Because if they were to get inside of us, they would get lost pretty quickly. The what?
Would they divide really quickly?
They don't divide, so there's a little piece of messenger
So
RNA.
then they just kind of die off because they don't have that coat.
They get degraded, yeah, they get degraded by all the RNAs and everything inside of our, they get anywhere, RNAs are everywhere. So these are similar to viruses, but they lack a capsid, so it's just a little piece of RNA. They may appear linear due to hydrogen bonding. How do you think these things get inside of plants? And this is kind of give you an idea of where they're.
Through the soil, like maybe through like the root system?
Oh. Usually going to be insects. These are usually going to be transmitted through insect vectors. Good.
So they're only, they only affect plants.
Only plants, yeah, because we would just degrade them so fast.
Is
that
that
they
what
can-
you were saying earlier? How some like plants are kind of like multicolored because of the viruses?
Yeah, but yeah. So they wanted to do that. So they'll put the genes, but I don't know exactly how it works. But those ones that are all kind of tie-dyed looking and stuff, usually those are from viruses.
That's cool.
And I don't know exactly how it works. All right, now we talked about. Remember we had that big genome and the little bacterial genome, and then you have the big giant bacterial genome. You have a little viral genome. Here is what the GMO bacterial phage T7, which was that little tiny speck. And these are these viroids right here. So they're just little pieces of RNA that go in there, and basically they just go in there and get copied. And again, we're not going to go too much because they're not medically significant, right? There's some different ones out there. These are medically significant. What's a prion? Proteinaceous infectious agents. Misfolded protein. Again, every one of my classes said, can we go over prions at all in here?
A little bit, just
Little
that they're
bit,
hard to kill and
Yeah, we want to run
And they hit
killing it.
one, they hit another one, and they changed.
Right, so they usually change it from the natural or cellular configuration is usually what? Alpha helices, and when they interact with the prions, cause them to refold into beta sheet. And again, since the function is related to the structure, what happens to the function? It goes away. So we talked about, so we kind of went over these pretty much, right? That's about all there is to them. So pre-prion, prion causes cellular prions to refold into this. Where do you find these? There was just a new one that just came up. I just saw in the news. So mad cow disease, right?
yeah.
And that really comes from where? You don't remember where I said mad cow disease? Where cows get mad cow disease from?
From their food source, wasn't it?
From sheep. So usually I think it's what they call scrapies. Remember they would grind up dead sheep and put them inside of the feed for the cows so they get more protein. And that's where that started coming from. And then we would eat the cows and we would get the prion disease.
So it comes from the sheep then?
Originally, yeah, it's called scrapies. Or scabies. The sheep with it would just scrape up against things until they would actually get raw. Now there's two human forms. What are the two human forms out there?
Didn't we say rabies?
Not
Or was that
rabies,
something
it's all
else?
prions, the prions. So there's Kuru, which is the one in New Guinea.
What is it? Cool.
Kuru, yeah, it's basically Creutzfeldt-Jakob's disease, which is the name of the prion disease that spontaneously happens to humans once in a while. But in New Guinea, when they would go to war, the winning tribe would eat the brains of the losers. So this thing sort of spread more and more and more to where it was actually common enough to get a name for it. They called it Kuru.
Kuru. Would that be Curoo?
K. So K.
K-U-R.
K-U-R-U, yeah, Kuru. Don't watch the Brady Bunch. It's the one in the Brady Bunch episode I told you all about. Now, we talk about chronic wasting disease in deer and antelope. Nobody hunts here, right? Anybody hunter? Sometimes? You are?
No, my boyfriend does.
Your boyfriend is? Do you do deer and antelope and stuff here around here, or?
Deer and clockwork.
So has he heard of the chronic wasting disease, the issue they have about that?
No.
Chronic wasting disease is a prion disease that's in deer and antelope and hoofed animals like that. Ungulates. And they didn't think it got into humans, so they weren't worried about it. Remember, we said that for prion disease to be infectious to another species, you're gonna have that protein, right? Otherwise, it's not gonna go bump into it and refold it if you don't have that protein, so they didn't think they had it. But now there's one lab in Canada that says it may be able to cause disease in humans. Just be careful with that. I haven't heard anything else about it. But, just to get on the top side of that, there was a guy in New York, did everybody see that one? And he's come down and died from Creutzfeldt-Jakob disease. And they think they traced it back to squirrel brains.
Oh.
Yes. Apparently in some parts of the country, squirrel brains is a delicacy. Probably some of my relatives. So, they think that he may have gotten Creutzfeldt-Jakob disease from squirrel brain. But the scary part about that is what? To me. Because it seems like it's more and more common than we really thought out there, that maybe in more and more different animals. We may all be vegetarians after all.
So is there any way to cure it once you have a disease like that? No.
No, there's no treatment, there's no cure, no
Because
treatment.
only
nothing.
heat, well, not even.
Huh?
I said was it only heat that could kill prions? I can't remember.
No, even the heat, it has to get super, super high temperatures and get sterilized.
You kill the host.
So
Yeah, you'd kill the host
yeah.
before you kill the prion.
Oh, yeah, you couldn't do anything like that.
Yeah.
So we have, all right. So again, right here, you got the normal prion right there, the cellular one. It bumps into it, causes it to change shape. Brown disease, the ones you know are spongiform encephalopathies. That's what it's called. That's Creutzfeldt-Jakob disease. Bovine spongiform encephalopathy, Kuru. And it's called that because what happens, what does the brain look like after
Swell?
a while? It looks like a sponge.
So that's Kuru. that you were
Kuru, yeah,
saying.
the Kuru is just Creutzfeldt-Jakob disease.
Okay.
It was just before, they was called Kuru before they really knew what it was. Digestion, transplantation, uses membrane for infected tissues, although I don't know if one of the questions on that. And prions are destroyed by incineration or autoclaving and concentration sodium hydroxide. Problem is, most things don't react really well to that. However, there is that new what that treats it now, from the last test.
Huh?
Can you repeat the question?
There's now a new thing to get rid of prions, not to treat it, but to get rid of it from the last test. Or maybe it's from the, last test.
Wasn't that gas?
Not ethylene oxide, no. You might remember, kind of went over kind of quick. Remember the priozymes, the enzymes, the proteolytic enzymes they have now?
Oh, that's right. Only enzymes can. I knew that.
So, that's one of them that does that.
It can treat it, or
Not treat it, because they probably would start going after the regular protein too. But just so you guys know later, a thing called proteases are enzymes that go after proteins. And you have a bunch of them in your body, they go after different proteins. So somebody just designed an enzyme that will break down those prions. Like I said, it was pretty smart, probably pretty easy, and I don't know why some of us didn't think about it. All right, that's it for viruses, guys. At least for characteristics of them. We will get to, when we get through this, we'll start getting into the organisms themselves. All right, this I think is going to be a lot more, A, interesting to you guys, and B, a lot more useful for you all too, right? Early for moment. All right. So this is going to be epidemiology, infectious disease, and how infections are spread, how they have what are reservoirs, where do they hide, how do they come out, right? So symbiosis means what?
to work with.
Together.
So living together. So we have symbiotic relationships with countless microorganisms, more than they thought from before. But what's mutualism, what's commensalism, what's parasitism? There's actually another one they threw in there.
I know parasitism is like when the organism just kind of feeds off of like the host and the host doesn't get really any benefits.
No, not only does it not get benefits, what happens if it's a parasite?
Just to kill them.
Not necessarily kill them, because if you want to be a good parasite, you want to kill your host.
No.
It leaches off.
But it harms them to some degree, yeah. Now, if you become, let's just go through each, but you're pretty much right with it. So mutualism, both organisms benefit. Bacteria in our colon, right? They break down, they make some vitamins for us, they break down some stuff we can't break down. And the flip side, we give them lots of food and a nice warm place to live, right? Commensalism is one organism benefits and the other one is neither harmed or doesn't benefit. Okay, it doesn't benefit, but it's not harmed. So one of them is getting something out of it, the other one is just kind of there. So, if you have staph epidermidis, what would that be? Not if, you all have it. Would that be mutualism? So parasitism is one of them benefits, the other one is harmed. Okay? So what would staph epidermidis be?
I still think it'd be mutualism.
Mutualism?
Cause they can't
Yeah, it would be
harm
harming
you.
the skin, so why wouldn't
Well,
it be
Well,
parasitic?
it might hurt you, but it still benefits itself.
It benefits itself, so that's gonna be a commensal.
Oh, okay.
Because this benefits from us, because it's got a nice place to live, it's got high salt, it can live there, a lot of things can't, but it doesn't really harm us. It doesn't benefit us either, really. It's not like it's one that really protects us, generally. Oh, it's even on here, dang it, I didn't even notice that.
So which staff is the one that affects us?
Staph aureus is on there too, but it's pretty much a commensal as long as, now we're gonna talk about this, we start getting into opportunistic passages, and some of them will be in this chapter. A lot of these things are commensals as long as they stay where they're supposed to be. If they get places they're not supposed to be, that's where they start causing problems.
And that's supposed to be on our skin?
Mm-hmm.
Oh,
Then I said on niche, it's carved out for itself.
oh.
Alright, so normal microbiota hosts organisms that colonize the body's surface without normally causing disease. That's your normal microbiota, your normal flora, your normal flora and fauna. There's about 10 different words for it, okay? Also termed flora or indigenous microbiota, depending on what book you get, it's got a bunch of different names, right? The idea is that stuff that's supposed to be there, it doesn't usually harm you. There's two types, resident and transient. Resident are part of your normal microbiota throughout life. And they're mostly going to be commensals. You're going to have a few that benefit you, but most of them are just there. These are the ones you start gaining right from when the day one when you're born. When you come out, right? You start populating this. In fact, there's a big new study on again on the benefits of breastfeeding, because, do you see that? Yeah, some of the microbiota are starting to do so. Alright, transient's a little bit harder. They remain in the body for a short period of time, found in the same regions as resident microbiota, but they can't persist permanently. Okay? Either competition from your normal flora is going to get rid of them, elimination by your immune system, or changes, chemical or physical changes in the body. So these things are noticing this change now too. In fact, this whole thing will change a little bit, because even your resident ones, they have found out change. They went and they did this study, they looked at some indigenous people down in the Amazon who didn't have any outside food or anything, and they checked their gut flora. And as their food sources changed over the years, over the seasons, their microbiota changed too. So this whole thing may change a little bit here.
Is that good or bad?
It was fine, it was good for them. I mean, it was just adjusting to the.
An adaptation.
Mhm.
Oh.
Now, we mess everything up with what?
Antibiotics.
Antibiotics, the big ones that cause problems for us.
So what would like probiotics fall under?
Oh, yeah.
Probiotics would be trying to, the idea behind probiotics is to repopulate your resident microbiota.
The resident.
Yeah, in fact, that bifidus one that you see in a lot of microbiota, in the probiotics, that's the one that's in breast milk and everything else. It's in right
So
away.
wouldn't it be considered transient, even though it's
No,
yours?
because normally it should be there, yeah.
Okay, so you're just enhancing your own.
Right, because the idea behind probiotics is we have bad diets, we take a lot of antibiotics, things like that, so you're constantly killing them off. Now, some of what they found out now, once you kill them off, you never get them back. Like that one that breaks down,
Lactose.
it breaks down oxalates. And so, once that one's gone, it never comes back. And that predisposes you to kidney stones. So, acquisition of normal microbiota, development in the womb free of They begin to develop during the birthing process. As soon as you start coming into the world, you start populating this, okay? Much of one's resident microbiota is established during the first months of life. So it's very important to take that kid out and roll it around in the dirt a little. Make sure you populate this thing up for them. And then you come right back around and do what? They get an ear infection, and what do? Give them a bunch of antibiotics and knock all that stuff down. Wait till you get some of the treatments we're going to talk about to restore some of these. Now, pathogens, there are things that are called true pathogens. And what is a true pathogen? Say what? It's going to, if you get exposed to a true pathogen, it's going to make you sick. If I give you salmonella, you're going to get what? You're going to get salmonella. You're going to get sick, right? Opportunistic pathogens are normal microbiota that cause disease under certain circumstances. It can be you become immunocompromised, or they can get in the wrong spots. So conditions that provide opportunities for pathogens: introduction of normal microbiota to unusual sites in the body. You get a nick in your colon, and those bacteria from your colon get inside of your peritoneal cavity. That is not good. So a lot of them do very good for you as long as they stay where?
Where they're
In your
supposed to.
colon. Staph aureus, does that cause problems as long as it stays in your nose? No, but if it gets somewhere it's not supposed to be, that's where you have problems. Other things that can cause it are going to be immunosuppression. Okay? Most people have strep throat, bacteria on them all the time. Do you get strep all the time?
No.
No. Changes in the normal microbiota. So changes in relative abundance may allow the opportunity for a member to thrive and cause disease. And this is probably going to be caused by what? What's going to cause a change in your normal microbiota? Huh? Antibiotics. That's one of the ones that does that. And the one we'll talk about later on is C. diff. That's one of the big ones. That's a problem. All right, most pathogens cannot survive for long outside of their host. Who here was told when they were growing up they get gonorrhea from the toilet seat? Did you know
My
that?
mom would
That's a
tell me that.
whole minefield. Can you get gonorrhea from the toilet seat? No.
Okay.
Somebody told somebody I knew they had long, it's a girl, she was a little girl, she had long hair, she had bangs. Some teacher told her she could get syphilis from her bangs.
What?
I'm not quite sure how she ever put those two together. But most of these pathogens, true pathogens, have evolved to the point where they do not do well outside of the body. Especially things like the venereal diseases, stuff like that.
They need that right temperature, right?
They need that temperature, they need they need the environment, they need everything, yeah. I think gonorrhea lasts for, I forgot how many minutes, but it's not very long outside of the body. If it just gets on something like on a toilet seat, if you were to get on the toilet seat. Right. Reservoirs for infections are sites where pathogens are maintained as a source of infection. We're going to talk about three types. We'll go into some more. Animal, human, and non-living. This is a huge issue because if you have a non-human reservoir, are you ever going to get rid of that disease? Why not?
Okay, if it's a non-living thing,
It's not non-living. Did I say non-living?
yeah.
Well, non-living too. I meant animal too.
Oh, okay.
But non-living too. I meant non-human. Okay, why were we able to eradicate smallpox? You might remember.
Vaccines. Wasn't it
The
vaccines?
vaccine, but why were we able to get rid of it? We have vaccines for a lot of stuff, you can't get rid of them. The what? Can't, they got generated the idea from cowpox.
Is it because we stopped new growth so it wasn't able to keep germinating, or?
Okay, how come we can't get rid of rabies, or we can't get rid of
Because other animals can transfer that too.
what? The reason we were able to get rid of smallpox is smallpox only infected humans. So there was no reservoir host for it. There was no animal reservoir for it. Right? It only infected humans. So once you successfully vaccinated most people, there was no more smallpox. They're trying to do it with polio, but they can't quite get it. Polio doesn't have any of the host to do with it. They're having a lot of trouble. There's three endemic areas for polio. Pakistan, Afghanistan, and somewhere in Africa, and I always forget where the one in Africa is. They cannot seem to eradicate it there.
In those countries?
Yeah, it keeps popping up.
Hmm.
Okay, a zoonotic disease is disease naturally spread from animal to humans. But zoonotic diseases, the big part is right here. Direct contact with animal or its waste, eating animals, blood-sucking arthropods. For most zoonotic diseases, though, humans are a dead-end host because they're not supposed to be in us. They can make us sick, and they can even kill us, but most of those diseases you cannot spread to other people.
Oh.
They're not going to be infectious, contagious, or communicable, right? Can you spread rabies to somebody else?
Yeah.
Hmm? There's actually not been a confirmed case of human-to-human spread of rabies just yet. Theoretically, could you? You could, possibly. It's one of the few, but usually by the time, rabies is very weird. Even animals are not, they're only infectious for a very short period of time. When they start actually getting kind of, that's when they're infected. The virus stays in the brain right before they really start going bad, it goes down to the cell, it gets down to the saliva. So by the time a human's that bad, they
They're
probably,
already hospitalized.
yeah.
They're already gonna die, right?
Right, so. So it's usually dead and host. Malaria, can you get person-to-person transmission of malaria?
I thought you could.
No, it's from.
Gotta be from insect to insect to person, insect to person.
Oh.
Now, I don't know, I mean, you probably can get it from a blood transfusion, that'll be that already, but that's not normal human contact, right?
No, but like in those old movies, I always thought because the doctor would always get sick and diabetes, but it's because he was probably also getting bit by the same mosquitoes.
Right, so yeah.
Okay.
Mosquitoes around. All right. So, why is this important? Like I said, are we ever gonna get rid of rabies?
No,
Why not?
because of the animals.
Because there's tons of, any warm-blooded animal can be a host for rabies, we will never get rid of rabies, at least not for a long time. How about Ebola?
We can't ever get rid of it.
What's the deal with Ebola?
Oh, is it from monkeys or something
Now,
originally?
the problem is they don't know what the reservoir host is. A reservoir host is an animal that keeps the infection sustained.
And they don't
And they
know.
haven't figured it. I think it's bats, I think, but I don't think, last I checked, they hadn't figured it out yet.
But they did find out that it was from an animal for sure.
Yeah.
Okay.
Yeah, it pops up somehow. They think HIV, where do you think HIV came from?
Oh, yeah.
That was from monkeys, they think, yeah.
Like a
People-
butcher that used to.
Yeah, it's called bushmeat, they call that, so people, yeah. So that's how they think the first HIV got spread, they think.
So how can they tell when it comes from an animal?
Because they can find it in animals. So what they're doing now is they're going out and they're trapping animals, they're trapping insects, and they're looking for Ebola and all those different types of things. So they're trying to track down how it's spread, if there's a different host that spreads it, and is there a reservoir host for it.
So, did you finish saying
Do
about
what?
Ebola? Did you finish saying?
Every single day.
Right, yeah.
Is that what?
It's hideous, like she's catching every single thing you can find and.
Oh, well, yeah, I mean, it's, keep people,
The more you catch,
keeps
the
that
more
grant
you
money
know.
coming in, huh?
The more you
The
catch, the more
Ebola
you
they
know.
haven't found.
Yeah.
um,
And you might
No,
catch
no.
something else that you might not even know about.
Right?
Yeah.
Alright, so we'll go back to this, we get to parasites later on, but parasites have a bunch of different, in parasites, there can be several different hosts for different organisms. What you need to know is the reservoir host, and that's the host that keeps the infection sustained in the environment, right? Yeah.
Quick question about Lyme disease. So that's a bacteria that's
Yeah.
in a tick, that's in a deer.
Yeah,
So like who's the reservoir in that? And it can infect humans. So like
it can infect humans, so one's gonna be the vector, that's gonna be the tick.
okay.
The reservoir host would be the deer, and things like that. And that's a good point. So things like that, you have one that's a vector, and that's the thing that's gonna spread it from animal to animal to animal. But the reservoir host is gonna be something like deer or like that. Now, there's some of them that the insects can act as both. They can be reservoir
Like
hosts and
mosquitoes?
vectors.
Mosquitoes, would they be both?
No, mosquitoes, they're probably, well, it depends on the disease, actually. Because they
What's
spread all
that?
kinds of stuff. Malaria, Zika.
Yeah.
I don't think they know what the host for Zika is, I don't know. And it may be mosquitoes, I don't know that much about that one. So there's some things that can be both. Which I think the virus can replicate inside of, I think that sounds like can replicate inside of the Culex mosquito, so I don't know, I have to look, don't know about that. Maybe I can go look at that. All right, a carrier is an asymptomatic infected individual, can be infective to others. Give me an example.
Oh, like we were talking about, well, we learned that it's changed, but that how boys can carry the HPV virus without symptoms and,
And they're gonna be asymptomatic for it, right? There's a
Mhm.
lot of things, a lot of the sexually transmitted diseases, people are actually what?
That's it.
Asymptomatic for it too.
Us humans.
Yeah, I mean, a lot of them, see, women are, a lot of times are asymptomatic for gonorrhea. They can be asymptomatic for chlamydia, I think. Men are asymptomac a lot of times for HPV more so than women, so it just depends. But how about hepatitis?
for years you will be.
Bobby, you can be a carrier for that too, right? Some individuals eventually will develop illness while others never get sick, and that's HPV's like that, but hepatitis is like that. Some people have hepatitis C their whole life, and they're still infectious, or hep B, but they never get sick, they never have liver damage.
Aren't some people like that with AIDS and HIV?
They are, but those what they call long-term non-progressors was the old term for them, now they call them elite controllers. And the other ones I talked about that mutation in that receptor,
Yeah.
they have that. But they can't infect other people.
I think even like some cancer. Like
What?
some people don't even know they have cancer until like they get diagnosed into like stage 4 already.
Yeah, well, that's where certain diseases, people talk about subclinical, that comes up later on, until it becomes, it reaches clinical significance. So you're gonna have subclinical disease, which is you have the disease, but it never gets to the point where it causes symptoms. And then you have clinical. All right, someone's okay. Healthy carriers may have defensive systems that protect them. We also talked about who here has been exposed to herpes virus 1.
Isn't everybody?
Everybody?
Pretty much everybody, because everybody here get cold sores. I don't want to know if you guys don't know my business. But they think almost everybody's been exposed to it, but a lot of people, their immune system's able to clear the virus without a problem.
Wasn't that also how they like tested to see how much like concentration you have? Cause like
Your titers, with the
Yeah, like-
viral titers, yeah.
yeah, cause like you won't be everyone won't be at like 0. Like someone's gonna have some percent, but at some point if it's higher than a certain, I think like number, I think it's like I don't remember what.
Is it for the herpes virus?
Yeah.
I honestly got me on that, I don't know. So everybody has, so you find a lot of people are gonna have a baseline titer of a virus,
Yeah.
free floating.
Yeah, like when you check, everyone's just gonna be at like 0 because everyone's been exposed. So everyone has herpes in them, but like it's like to a
Now, are
certain
you
level.
looking for antibodies, or are you looking for the virus itself too? Because there are two different titers they can look at. They can look at viral load, which is actually virus, and they can look at your antibody titer, which is the amount of antibodies you produce to get something.
Oh.
So I'm not sure which one that would be
No,
there.
I don't know.
Yeah.
Because I know the titer one looks for your antibodies.
Right. So the virus one, so maybe it may be that you shed virus, everybody who has it sheds at a very low level constantly.
Mhm.
And then at some point it'll come out and you'll be producing so much virus that'll cause symptoms, so. Alright, so non-living reservoirs are gonna be what?
Soil, water.
Soil, water, food, anything. They found, wherever they found bacteria now, floating around. They have found bacteria up in the atmosphere that came from Saudi Arabia.
Wow.
And it gets kicked up in the air, gets in the air currents up there and just rides them over. Non-living reservoirs can be pretty much anything. Presence of microorganisms often due to contamination with species in urine from animals. That's how they think. And that was the thing they were wondering about the prion disease in deer. Do deer go around eating each other? You ever seen a carnivorous deer? No. So one of the things is, how is it spread? When they think, they're pretty sure it's spreading out through urine. And so a deer will go and, they'll be grazing and they'll urinate and they'll put it out there, and then some other deer will come and eat right where where that one had urinated. All right. Human carriers. Need to put more in there about that. What's the difference between contamination and infection, and then we'll talk about what disease is. So contamination is the mere presence of microbes in or on our body. So every one of us is what?
Contaminated.
Contaminated, all right? So you all got cooties out there, right? Infection is when an organism evades the body's external defenses, gets a foothold, and multiplies, and becomes established in the body. Does that necessarily mean you have disease at that point? Yes or no?
No.
No.
No, you can be infected but not have disease, active disease. What is disease? I thought I put disease in here now, I guess not.
It's already taken over.
Disease is when you start getting a change in your physiology. So that's when an organism is causing an issue, so you're getting some sort of change physiologically, okay? So if you have hepatitis C and you're a carrier, are you infected? Yes, because it's inside of you, it's multiplying, it's got a foothold, but is it really causing any disease at that point?
No.
Most people don't know they even have it, right? Some people get sick, some people will. All right, portals of entry are sites through which pathogens enter the body. Three major pathways: skin, mucous membrane, and placenta. Okay. This means the bacteria get in through these, okay, or the virus gets in through these, or the parasite gets through them. Parenternal are routes that circumvent the usual portals. So what would the parenternal be?
Means that you got
Nope, it's just, it's kind of a weird word, actually, yeah. It parenternal just means that you're circumventing one of your normal barriers. Right? So what would an example be? If somebody got an infection through a parenternal route?
Normal
Well,
barrier.
That's probably gonna be a mucous membrane.
Would it be like meningitis? Because it goes in through your nervous system and then moves out the brain barrier?
Nope,
Just
it's gonna be
portals.
mucous membrane.
like tetanus.
Tetanus?
Like stepping on a
Good.
rusty nail.
Oh.
Anything like a splinter or a nail or a thorn or anything like that's gonna breach your skin and get inside of you, that's gonna be parenternal. When they mean skin, they mean the organism is actually infecting the skin itself and
This
getting
is
through.
bypassing.
Bypass it. Parenternal is some way you circumvent that way.
So like, if you already had a cut though, would that also be one of them? Apparently.
Yeah, because whatever caused that cut would have been that way, so. And if, let's say you got an injection and you got sick from that, that would also be what? Same thing, right, parenternal? Now, yeah, because entries via parenternal route circumventing, so even a cut, even if you got a cut, they got something on it later, I wouldn't consider that parenternal also, because that skin's been breached, the organism itself didn't do it. So, tell me something that can affect the skin.
Like staphylococcus.
Yeah, but is it infect your skin usually? Now, can it?
What about
You can get staph infections, right? Skin staph infections. What about
tuberculosis of the skin?
TB in the skin? What's that one? I've never seen it.
Yeah, I was watching it in Mr. Nunez's class.
Is it? It's not avian, is it?
Um,
Oh, you're not talking about leprosy.
yeah.
You're talking about leprosy. Okay, yeah, that would be one. That does, yeah. So leprosy would be one.
Can't anthrax or
Cancer can be cutaneous too, but I'm not sure if you have to get a rupture in the skin or if it can actually go after the skin itself. I need to look into anthrax on that. How about HPV though?
Oh yeah.
What does it cause?
Warts.
Warts, right? Does it actually get inside of you and then come back around? No, it actually infects that outer layer of skin, right? Or mucous membrane.
So like chickenpox is that?
Chickenpox is gonna be how chickenpox? Chickenpox is mucous membrane usually.
Mm.
It's gonna get inside of you. And then, of course, that would be the same thing. That would still be a mucous membrane, right?
Mm.
Skin's just the one that's kind of hard for people to get a grasp of. How about regular warts?
Yeah.
How do you get those?
Touching a frog.
It's just gonna be contact, right? So that's when it's gonna get skin. So. Some of the other ones you can get from skin are gonna be fungal infections. How about athlete's foot?
Mm.
It's gonna be the skin, right?
But would it just be just contact, or would it have to like get underneath your skin?
Well, that's what they're talking about. If it can actually infect the skin itself, that's gonna be a skin. That's gonna be going through that pathway. So like dermatophytes or fungal infections that just infect the outer layer of your skin. That's gonna be things like athlete's foot and what are the other ones? Jock itch, what else? It's all the same, basically the same thing, getting your hair and everything else too. But if it's something that has to get a foothold via a breach in that barrier, that's gonna be parenternal. Okay, that's the one that's really bad now, it's one of the, Vibrios. Now, if you eat the shellfish with this Vibrio, it can get inside into your stomach and do what to you? If you're immunocompromised. If you happen to be walking in the ocean and you step on one that has this Vibrio in it and you get a cut, which is the parenteral route, you can get a nasty infection, and then in fact, there's some poor guy lost like both of his legs or something from the infection and goes septic on him. Alright. So portals of entry, skin is the outer layer of dead skin cells acting as a barrier to pathogens. However, some pathogens can enter through openings or cuts, that's the parenteral route, it's gonna be a breach in there. Others enter by burrowing into the or digesting. Let me try that again. Others enter by burrowing into or digesting the outer layers of skin. This is one that's going to be skin. It's actually going through the skin itself. Okay? It's not breaching it. So I don't know, what do you guys think? I'm going to ask your own opinion. So there has this book is saying some pathogens can enter through openings or cuts. And not like through a sticker, so maybe like what you were talking about. So what do y'all think? Would you call that the skin?
Yeah, I'm calling it skin.
You guys would call it skin? See, to me, there's been a breach in that barrier, so I would think of it as being
Then
parenteral.
I think it depends how
But,
big
like,
the
if
cut
it-
is too.
And it may be, they may be thinking that for the parenteral, I'm thinking this may be for the parenteral, it must be actively from that initial.
Like the nail.
Yeah, because like, what
or
if you already
something.
have a cut and like you disinfected it, you're taking good care of it, so then another like.
Right, so yeah, that's what I think they're saying here. So I guess so, we'll go ahead and call that skin too, which is both of us for sure. To me, anything that artificially breaches the skin, but it's just differences of opinions. Mucous membranes line the body cavities where they're open to the environment, provide a moist, warm environment, hospitable to pathogens. In fact, there are a lot of pathogens that have evolved just to live on mucous membranes. The respiratory tract is the most common site of entry. Entry is through the nose, mouth, or eyes. This is one big common one right here, because all your nose, your mouth, and your eyes are all what?
Connected.
Connected. Gastrointestinal tract may be a portal of entry. You've got nice mucous membranes in there. And then where else? Urogenital tract. Anywhere along the urogenital tract, you have some mucous membranes, right? And that pretty much covers all the mucous membranes. Most survive. They must survive the GI tract, the acidic pH of the stomach, because that's a good barrier too. Most things can't do that. Some of the pathogens. Now, when could you get through the stomach more easily if you're a pathogen?
You're an acidophile, maybe?
If you're an acidophile, you could, but then you're gonna have trouble once you get inside the small intestine, because then it becomes alkaline.
Oh.
Hmm? How can you get into, how could an organism more easily get through the stomach?
If it's those ones that are covered, the like the enveloped ones, like the
Viruses?
like the one with the capsid, or is it?
Are you talking about like spores and cysts and things like that?
Yeah, I guess so. With the
Some of
capsid.
those can, in fact, some of the parasites actually have to go through the GI tract in the stomach to get rid of the cyst. So parasites that can do it for sure. But how about bacteria? How can you more easily get through there? When do you think they might more easily be able to get through there?
Maybe they like, and when you eat like your food, is it like inside the food, so then all the food gets disintegrated by the time you
So
can
it kind of gets mixed up pretty well in there. But what happens to the pH of your stomach when you eat a big meal? Lowers?
Acidity.
Starts to go back up, right? I mean, it's not go back up. It gets a little less acidic because you start diluting it out, and then you start putting more acid in there, ideally. But that may give you guys some time to get through there, too, where the pH gets a little higher. How about people taking those proton pump inhibitors and stuff?
Oh yeah.
That's been some concern. They've noticed that some people who already have liver disease, if you take those proton pump inhibitors, they're getting more enterococcus fecalis in their liver, exacerbating the liver damage.
So
anything that might change the pH, you maybe do.
Is that how ulcers that are caused by viruses, like
The ulcer, what causes ulcers now?
Viruses, aren't they?
Not a virus. H. pylori, the bacteria. It's a bacteria,
bacteria?
it's in the symphile, it's found a little niche in there, 95% of all ulcers now are caused by H. pylori. Yep.
How do you get H. pylori?
They don't know exactly, they think it's just kinda out there, so I don't know. I don't know what it's, where it, how it can be a free living organism. I really don't know that much about H. pylori, I've never really looked into it, I probably need to. But, it's gotta be somehow, right? And I don't know how, I don't know if it lives in, I don't know, I'm gonna have to look, and you gotta give me homework this evening. Now I gotta look up H. pylori reservoir. Because some people have it, some people don't, some people end up with it. Because, I got tested for it, because I was having some stomach issues, and I'm negative for it, but the guy said you need to come back and have it again, because, and he didn't tell me how it might get it either. Maybe it's just
They just treat it.
magically appears, I don't know, spontaneous generation. It's gotta be somewhere, gotta have some reservoir host, I just don't know what it is. I'll look into it this weekend. It's my weekend. But what's the other problem aside from ulcers with H. pylori? What do you increase the risk of?
Cancer.
Stomach cancer.
Wow.
Shoots up your chance of stomach cancer big. So, all right.
Isn't it saying that most bacteria and stuff like that, for it to like divide, it needs like a certain body temperature? Well, a lot of people now are doing these like really cold like tanks. Like, I don't know if you've seen that. They're in like,
I haven't
it's
seen
almost,
that.
almost looks like dry ice. I mean, and they're like in these tanks, and it's super super cold, and it's
And they're
supposed to
trying to
help
get rid
with
of it?
like.
Well, it might, because most pathogens will be involved. That's why you get a fever. You're trying to do the opposite of that. The fever is an attempt to raise your body temperature enough where it becomes unfavorable for the pathogen, because most of them like to grow at about 37 degrees
So then,
centigrade.
like, but if that person like didn't they have a higher chance of being sick because like they're really cold, or does it do the opposite, kind of it starts to kill off?
Yeah, probably it's the same, probably kind of the same thing, because you gotta be careful, because you can't get too high of a fever, because what happens to you? What's the high fever? Somebody here ever had 101 fever?
I've had under
Yeah.
4.
104, how did you feel at 104?
My head was like gonna burst. And it was
Were you?
No, I was saying 104 is already dangerous, so.
Yeah,
I was in the
104.
hospital.
You're 104, 105, you need to be in a hospital.
I was,
If
yeah.
they can't get it down, what do?
They
I
put
heard
you in
ice.
ice.
They put you in an ice bath, because you just can't stay up. Now, little infants, they can get up like 106, 107, they're like, no big deal. I don't know why, their little brains are better than ours. But yeah, so they'll put you in an ice bath, so it may be an attempt to do the opposite, although I hate being that cold. So
It hurts.
Yeah, because you're like all you wear is like your underwear and like that's it, and then you're in this tank. You can see like the cold, like all the fog coming out.
They just put like ice packs under
I don't
like.
remember what it does.
Oh,
Like, for
that's
you.
another-
But I always thought that the purpose of a fever was to destroy the bacteria with heat. But I've learned, I don't remember if it was in pharmacology or in anatomy, that the purpose of a fever is to release iron or something from your liver or something.
No, actually, it sequesters iron.
Oh,
Because a lot of
sequester.
bacteria need iron, so it helps sequester iron. It does a lot of things.
Yeah.
It also, all your cytokines and everything work better at higher temperatures, so it's just a whole part of that inflammatory response.
Okay.
But part of it, it's not gonna kill the bacteria or the virus, but it may inhibit their growth. So they slow down. Yeah,
okay.
it helps sequester iron.
Okay. So just the heat is just one aspect of a way to
It's just
denature
one,
it,
yeah. That's
but your
it.
body uses the heat also too.
Yeah, all your cytokines, all your chemokines, all
Yeah.
those work much better with a higher temperature. So it's just a whole part of the response. Which gets me to the point, should you take aspirin then? If you're
Yes.
sick?
They're saying no now.
So what does aspirin do? I wanna get my fever down. What's the whole point?
I would just say no med. I don't know why parents right away just give their kids meds.
Well, when my son was little, they would tell us to give him Motrin or something before a vaccine so he wouldn't get a fever. And, and that was what, 15 years ago? So, I don't know. But now they're telling parents, because my best friend just had a baby, that
Yeah.
not to do that, that let him have the fever unless it gets too high, then treat it.
Yeah, yeah, I mean, the whole idea is the fever is both, but the difference is something like a cold or the flu, unless you get a secondary infection, are you gonna be, is taking aspirin really gonna have that big of an effect on the overall immune response? Not really. So it's not that big of a deal. The thing with the vaccine, that's kind of weird.
Yeah. They would even give it to him at the doctor's office.
Listen,
My poor
taking
kid.
part of the effective barrier, this is called one of the privileged sites. You have the blood-brain barrier, you have the blood-placental barrier, and you have the blood-testes barrier. Well, half of us do. Right? What do those blood-brain barriers do? The idea is to keep pathogens out and to keep toxins and things out of those areas, right? But some things can cross the placenta and infect the fetus. They can cause spontaneous abortion, birth defects, premature birth. What are some that can do that? Does anybody know?
Syphilis?
Syphilis? What else? Syphilis cross the placental barrier, or is that during birth?
It's during birth.
During birth.
Yeah.
Taylor gonorrhea.
I'm thinking it was, it's not during
Which one?
the pregnancy?
Yeah,
Syphilis?
during the pregnancy, can it cross and down? Which one? What are some of the ones that can actually get through the?
So it can, syphilis can.
Some, no, some
Zika?
can't.
So it's not till the baby is
It's
born?
not till it's born, yeah.
Yeah.
Most
that's
of
travel.
the venereal ones are during delivery.
Zika?
Yeah, Zika again,
Yeah.
theoretically. What's the one they tell you not to change the cat litter box when you're pregnant?
Oh
That's the one
yeah.
thing you learned here about the animal host.
Yeah, toxoplasmosis,
Yeah.
that's the one. Listeria, my favorite bacteria of the day. It can cause, and it's some of the viruses can cause too. I thought I had some lists up here. Yeah, right here. Here's some lists right here. Toxoplasmosis gondii. Oh, no, you're right. Syphilis can cross the blood, can
Yeah,
cross the
that's-
placental barrier.
I had a,
I thought it was during delivery. It's not, it can't cross. Listeria, cytomegalovirus, HIV lentivirus, German measles. What else can toxoplasmosis been linked to? Anybody know? They used to think in adults it was just you were just a carrier, because most people have it. What has it been linked to now?
I just heard a podcast on this the other day.
And
I forgot.
anybody know?
Huh.
Pretty scary actually. They've linked it to schizophrenia now
Oh.
because it gets in the brain. So there's a pretty
So
positive
it-
correlation between schizophrenia.
Causing?
Yeah.
I heard that when rats get this, it makes cat piss attractive to them, so then they come towards it and then they,
Well, it also gets rid of their fear response too.
is that what that
Yeah,
is?
so they get toxoplasmosis infection that gets in their brain and it gets rid of the fear response. So you'll have a mouse and you put a cat there and the mouse will just sit there like. Alright, let's go ahead and stop here, we'll finish this up.
This is interesting.
Yeah, that's not, I mean, I want to get the other email and get some more stuff. And I want to go back and look through some more of the reservoir, I want you guys to look through some of that.